Hi everyone. Just going to go through the lesson today. We're talking about special triangles, and we're talking about the unit circle as well. So the key thing to remember is the unit circle is it's a circle with a radius of 1. Radius of 1, and we're going to use the special triangles to try and set up this unit circle. This unit circle is not designed to be something that's beautiful by the end and you're going to have it forever and it's going to be fantastic. You can print ones off the internet that are better. This is going to be a learning tool. So we're going to be setting it up and creating it, and we're going to write on it and have to do some figuring and stuff, but that's okay. Before we get started with the actual unit circle, we have to remember a few things. So I'm going to scroll down a little bit. I'll physically scroll down, the old-fashioned scrolling down. And we're going to talk about the special triangles. So from grade 11, the special triangles, there's 2 of them. The first one, they're both right angle triangles. Here's a right angle triangle, and you've got 30 degrees and 60 degrees. This is not to scale, obviously. So this special triangle would be 1 across from the 30, 2 would be the hypotenuse, and then you can use the Pythagorean theorem to figure out the third side is root 3, so the root 3 is across from the 60. So this is one of the principles of triangles. The smallest angle is across from the smallest side. That's how I remember it. The largest angle, which is 90, is across from the largest side, which is 2, and then the other one is the one in the middle. So that's the one unit circle you should remember from last year. The other unit circle had 45-degree angles in it. So 45 degrees, we'll angle there, and then it would be 1, 1, and this one, by using the Pythagorean theorem, would be root 2. Why did I write 3? I didn't know. Root 2. So that should say root 2. With what we did yesterday with radians, we're going to take these and change them into radians. So the first one in radians, I'm going to make it a little bit bigger. First one in radians, 30 degrees, you can change it over to radians. 30 degrees would be pi over 6 radians. 60 degrees would be pi over 3 radians. And I didn't write it in here, but 90 degrees is pi over 2 radians. So the other parts don't change, so the smallest side is across from the smallest angle. The smallest angle is pi over 6, which is 30 degrees, so that's going to be a 1. The hypotenuse is still 2, and then this guy's going to be root 3. Same idea. 45. Very similar, so we've got the right angle. Got pi over 4 for 45 degrees. You can check that out. Pi over 4. This would be 1, 1, and root 2. So those are our special triangles. The other thing you need to remember is the cast rule. Well, we don't actually need to remember it for setting up the unit circle, but it'll be helpful. I actually don't like to call it the cast rule. My beef with it is the cast rule starts in the 4th quadrant, which I think is weird. I think it should start in the 1st quadrant. So what this means is in the 1st quadrant, all of the trig ratios are positive, so sine, cos, and tan. In the 2nd quadrant, only sine is positive, cos and tan are negative. In the 3rd quadrant, only tan is positive, and in the 4th quadrant, only cos is positive. Okay. This also relates to the reciprocal trig ratios, so they'd all be positive. In the 2nd quadrant, sine is the reciprocal of cosecant, so this would be cosecant. Tan is the reciprocal of cotangent, so this would be cotangent. And then in the 4th quadrant, you would have secant because it's the reciprocal of cosine. So that's a lot to that's a lot to remember from grade 11. So hopefully that jogs your memory. Going back to the unit circle, so we're going to use this information on the unit circle. So if I scroll up on the unit circle, again, old-fashioned scrolling, not actually scrolling. I'm going to write on here. It's going to get messy. So the first thing I'm going to do is I'm going to take the 1st quadrant and I'm going to cut it in half. So this is going to be 45 degrees. So there's my 45 degrees. I'm going to do the same thing for 30. 30 would probably be around there-ish if I was doing it to scale. I'm not going to do it to scale just to give myself some more space. So I'm going to cut it right in half, even though it's not really. This would probably be about 22 and a half, but I'm going to call that 30 degrees. And I'm doing the same thing for 60. So I'm just spreading them out to make it look better. So this is going to be 60 degrees. And then, of course, we have 0 degrees, and this is going to be 90 degrees up here. So there's the 1st quadrant all labeled. What I need to do is I need to go around, and I'm going to make a little legend up here. So in black, I'm going to have degrees. And I'm going to do the same thing and go around the unit circle, but I'm going to do it with radians as well, because now we're working with radians. So in blue, I'm going to put radians. So I know that 0 degrees is 0 radians. 30 degrees is pi over 6 radians, which we already came across. 45 is pi over 4 radians. 60 is pi over 3 radians. And 90 is, I'm going to write this one, rated above pi over 2 radians. Okay, so I'm just starting off with the first quadrant. We'll worry about the other quadrants later. What I need to do now is I'm going to put the coordinates on here. So the coordinates, I'm going to put them in red. So in red is going to be coordinates. And what I have to do is figure out what the coordinates would be at each one of these points. So the 0 and 90 are pretty easy. The coordinate here is going to be 1 and 0. That's not rocket science. This one up here is going to be 0 and 1. Almost was too hard for me there. So now, if I think about the x and y coordinates, so I need the x and y coordinates for that point there. So what you're doing essentially is dropping down a 90 degree angle, dropping down a line to make a 90 degree angle, which would be called an altitude, is the word I was looking for. I know that the radius would be here, so that's the radius, and then this length would be x, and this length would be y. So what you have to remember from last year is that just using trig, the angle theta would be here, and like I said, I'm drawing all over this. This is not going to look pretty by the time I'm done. So here's the 30 degrees. So if I want to figure out how the first coordinate here, I need an x coordinate and a y coordinate. If I want the x coordinate, I would use x is adjacent to theta, and r is the hypotenuse. So if I wanted to work that out, I have r, theta, and x. So I've got adjacent over hypotenuse, so that would be cos. So I would be using cos theta is x over r. So cos theta, and this is 30 degrees, so I go back to my unit circles from down here. Cos of 30 degrees, or cos of pi by 6 radians, would be root 3 over 2. So cos of pi by 6 would be equal to 3 over 2. And then the radius is 1, so it would be over 1, but that really doesn't affect it, the over 1 part. So that is my x coordinate. So on the unit circle, I can put root 3 over 2. For the y coordinate, I'm doing a similar thing, except for the y coordinate, I'd now be using sine. So I'm going to write down here, here's my triangle, put theta, r, and I want the y. So it would be opposite over a hypotenuse. So opposite over hypotenuse is sine. So sine theta equals y over r. And if I want to solve for y here, I would be multiplying both sides by r, but 1 doesn't matter. So just like it didn't matter in the cos. So if I want, what am I here? 30 degrees, or pi over 6, sine would be opposite over hypotenuse, so 1/2. So the sine of pi over 6 is going to be 1/2. So then my y coordinate, and again, it's going to be over r. So this whole thing is equal to y. So my y coordinate is 1/2. Okay, and you can double check this on your calculator. Now my calculator is a little weird. It's maybe different than yours. But what you want is, you want to be in radians. Right now I'm in degrees, so convert to radians. Mine's under the mode, so I'm changing mine over to radians. Don't need gradients like we did yesterday. Cruel math joke. Okay, so if I want to work out cos pi by 6, cos pi divided by 6, it tells me it's root 3 over 2, which matches what I have. If your calculator gives it to you as a decimal, you're looking at 0.8660, which is the same as sine or cos 30. So sine pi by 6, I'm going to go sine pi by 6. I get 1/2, which is what we got. And if your calculator gives it to you as a decimal, it's 1/2, so it matches. So far, so good. So doing the exact same process for 45, so 45 degrees, I'm using this unit circle down here. So for the x coordinate, it's going to be cos. So it's 1 over root 2. And we'll worry about rationalizing this tomorrow or the next day. Don't worry about the root 2 in the bottom for now. The y coordinate is going to be sine, so opposite over hypotenuse, 1 over root 2. So those are our coordinates at 45 degrees. At 60 degrees, I would have, I don't know, I should have done this all beside, I guess. So at 60 degrees, I'm going to have, again, the x coordinate. So I go back to my unit circle. So 60 degrees is pi over 3 radians. So pi over 3 radians is, for the cos, it's going to be adjacent over hypotenuse. So 1 over 2. So I go back up here. It's going to be 1 over 2. For the y coordinate, so the y coordinate you sine from down here. So I need pi over 3. Sine would be opposite over hypotenuse, so root 3 over 2. So the y coordinate is going to be root 3 over 2. I should say root 3 over 2. So those are my coordinates. So just, I guess, as a summary, the x coordinates are going to be equal to r cos theta, but the r is 1, so r cos theta. And the y coordinates are r sine theta. Again, r is 1, so it doesn't matter. Okay, so hopefully that should make some sense. Linking it back to what you did last year, but the only difference is now we have these radians on here. So my radians are all the blue ones. So 0 radians, pi by 6 radians, pi by 4 radians, pi by 3 radians, and pi by 2 radians. Okay, so if you wanted to work this out on your calculator, just flip it around the other way. So if I know that cos of pi by 3 radians should be a half, so if I punch that into my calculator, cos of pi divided by 3, it should give me a half, and it does. So it works. You could flip it around if you wanted to go. Mine's different. I don't have to hit second function on mine, but cos inverse of 1/2 or 0.5, it better give me pi by 3. So it gives me 1.047 blah blah blah. To make sure that that's pi, this is pi by 3. So if I multiply this by 3, or if I just double check pi divided by 3, it's the same decimal. So that's probably the better check. Pi divided by 3. Compare it, make sure it's the same decimal, which it is, so I'm good to go. So that's just a little bit of the calculator stuff. We're going to be trying to work with exact values here for a while. So I'm going to do the same thing in the second quadrant. And note that in the first quadrant, all of the coses, which are all the x coordinates, are, well, that's not really in the first quadrant, but all of the cos values are positive because it's from cast, or all sandwiches taste crummy is how I remember it. So in the first quadrant, everything's positive, so all the coses, all the sines. To figure out tan would be equal to, I'll write this over here, tan theta is equal to sine theta over cos theta. So the tan values would be a positive over a positive over a positive, which would be positive, so the tan values would also be positive in the first quadrant. Okay, so that's the first quadrant. Let's go to the second quadrant. So I'm going to cut this guy in half. I'm going to try and pick up the pace here a little bit. So there's my 135 degrees. This is going to be 120. And then I've got 150 over here. So that's 150 degrees. Again, not to scale. Keep going around the unit circle. So this would be 180. The next one would be cut that in half. It would be 225. It's 225 degrees. After that, in here I have 210 degrees. And then down here I've got 240. This would be 270 degrees. This is going to be 315 degrees. 300 will be down here. And last but not least, 330 degrees. Okay, and if you want, you can continue to 360 degrees. And it keeps going around and around and around. It goes forever. Okay, so if you want, pause that, make sure you've got all your angles in the right spot. After, I am going to, right now I'm going to start putting some of the radians in. So first off, that's pi by 2 for 90. This has got to be pi radians. 270. So if that's, I'm going up by, so 0, pi by 2. This would be 2 pi by 2, 3 pi by 2. So this is 3 pi by 2 radians. Okay, and I'm going to do the 45s next because I think that's the easiest one, the next easiest one. So 0, 1 pi by 4, 2 pi by 4, which reduces to pi over 2. So 2 pi by 4, 3 pi by 4. So this is 3 pi by 4. I'm counting by pi by 4s. So 3 pi by 4, 4 pi by 4, which reduces to just pi, 5 pi by 4, 6 pi by 4, this would be 7 pi by 4, and then 0 would be 8 pi by 4, or 2 pi, which is what we talked about yesterday. 2 pi is all the way around the circle. Okay, so that's that. Let's go to the 30s. So I'm going 0, 30, 60, 90, so I'm counting up by 30 every time, so I can just use these fractions to help me. So 0, 1 pi by 6, 2 pi by 6 reduces to pi over 3, 3 pi by 6, this would be 4 pi by 6. I jammed it in there. 4 pi by 6, 5 pi by 6, 5 pi by 6, 6 pi by 6, 7 pi by 6. Get ahead of myself there. Too excited. 7 pi by 6, 8 pi by 6, which should reduce to 4 pi over 3. Just caught onto that. 8 pi by 6, which is the same as 4 pi by 6. 4 pi by 3. 4 pi by 3. Shut off my brain there for a minute. 4 pi over 3. Okay, I lost track of what I was doing here. This guy should reduce to. This guy should be 2 pi over 3. That's what you want there. 4 pi by 3, I wasn't reducing. So, where was I? 1 pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, 5 pi by 6, 6 pi by 6, 7 pi by 6, 8 pi by 6, 9 pi by 6, which is 3 pi over 2, 10 pi over 6, which reduces. I'll reduce it this time. So 10 pi over 6 would be 5 pi over 3. Both pi by 2. 5 pi over 10 pi over 11 pi over 6, which doesn't reduce. So this is 11 pi over by 6, and then 12 pi by 6, which reduces to 2 pi. I hope I haven't confused you with the fractions. I forgot to reduce them. So that one's 4 pi over 3 reduced. This one's 2 pi over 3 reduced. So that's that. If you take what we did here with the coordinates, so I've got root 3 over 2 and 1/2 over here. So if I flip that over here for the 150 degrees, so the only thing that's going to happen is the y-coordinate will still be a half, because it's the same height. The x-coordinate, though, is going to be negative. So this is going to be negative root 3 over 2 and 1/2. So the x-coordinate switches, the y-coordinate does nothing. This guy is going to be negative 1 over root 2 and 1 over root 2. And again, if you learned how to rationalize the denominators last year, don't worry about it for now. We'll deal with it later, tomorrow or the next day. This is going to be negative 1/2 and positive root 3 over 2 as that coordinate. So like I said, this is not intended to be beautiful. It's thinking. We're trying to think our way through this. Over here, this is just 1 as a radius. So this is going to be negative 1 and 0. Okay, so now, once I've got, for the third quadrant, once I've got the second quadrant, I can flip them this way. So if I start with this 150, or this 5 pi over 6, and I go to 7 pi over 6, I'm flipping this coordinate down here. So the only thing that's going to change is the y-coordinate. So the y-coordinate is now going to be in the negatives. So this is going to be negative root 3 over 2 and negative 1/2. Okay, so coordinates just flip down here. So that shouldn't change it. The light went off. Hopefully that doesn't change the lighting for this. Make it a little bit brighter maybe. I don't know if that helps or not. The 45, or the 225, which is the 3 pi over 4, negative 1 over root 2, that's going to be the same, but the y-coordinate's going to flip down here, so it's going to be negative. So it's going to be negative 1 over root 2, negative 1 over root 2. So it looks like that. This 4 pi over 3 is where the 120 was, so it's going to flip down. Same idea, so it's going to be negative 1 over root 2 and negative root 3 over 2. Won't need 1. I got that wrong. It's 1/2. It's messy for another reason now. That should say root 2. I'm going to wipe that out. My apologies. I'm trying to do this without stopping the video. I'm just going to come back to it. Hopefully it's dry by the time we're done. Okay, so fourth quadrant. It's pretty easy to see that this one's 0 and negative 1. Again, because the radius is 1, so it would be negative 1 down there. To get this guy, the 300 degrees, the 5 pi over 3, it's 60 degrees flipped down here, so it's going to be the same x coordinate, but the y coordinate is negative now. So this guy is going to be 1/2 and negative root 3 over 2. This 7 pi over 4 is the pi over 4 flipped down, so it's going to be 1 over root 2, negative 1 over root 2. 1 over root 2, negative 1 over root 2. And then last but not least is this guy, root 3 over 2 and negative 1/2. And you can check any of these and it should work. So while I'm waiting for the whiteout to dry, I'm going to check a few of these. So if I wanted to check, and make sure your calculator is in radians. So I've got radians here. So I don't know if you can see this, hopefully. It's kind of fuzzy on my screen. So if I wanted to work out sine of 7 pi over 6, so sine of 7 pi over 6, it should tell me that sine is going to be the y-coordinate, so it's going to be negative 1/2, hopefully. And it is negative 1/2, so it works. If I wanted to work out, I'm going to leave the 45s for a second until we start rationalizing, because well, let's try it, what the heck. If I go, let's try 3 pi over 4. 3 pi over 4, cos of 3 pi over 4 should be the x-coordinate, should be negative 1 over root 2. So cos of 3 pi divided by 4, and I get negative root 2 over 2. So that is the same as this. We'll worry about how to rationalize the denominator later. It was too much to take on in one day, so we're doing that first, or we'll do that tomorrow or the next day. But these are the same thing. If you change that to a decimal, you get negative 0.707. If I go negative 1 divided by square root of 2, I get same thing, negative 0.707. So same things, we'll worry about rationalizing later. I think this might be dry enough now, so I can write in my, this was 4 pi over 3, so it should be the 4 pi over 6 flipped, so it should be negative 1/2. Negative 1/2. So that's what that should look like. So that's what it should look like completed. We'll use it for a few questions in a second. We're already at 23 minutes, so it's getting a little long in the tooth here. I'm going to move this over, and then we're going to do a couple examples. So if you need to, you can pause it, but that's kind of what you should have. I tried to color code it as best I could. So for this example, it says determine the 6 trigonometric ratios for the angle 4 pi over root 3. So 4 pi over root 3, I need the 6 trigonometric ratios. So the 6 ratios are sine, cos, tan, and then cosecant, secant, and cotangent. So what I'm going to do is think about this angle, this 4 pi over 3. You can use the unit circle. 4 pi over 3 is going to be in the second quadrant. So, sorry, that's a lie. It's in the third quadrant, 4 pi over 3. So 4 pi over 3 is here on the third quadrant. So if I want to work out sine of 4 pi over 3, cos of 4 pi over 3, and tan of 4 pi over 3. So sine and cos are easy. Sine is the y-coordinate, so you look on your unit circle. The y-coordinate is negative root 3 over 2. So it's going to be negative 3 over 2. Cos of 4 pi over 3, that's easy. That's the x-coordinate. So the x-coordinate is negative 1/2. Well, good thing we fixed that one because that's the one we needed. Negative 1/2. And then for tan, to work out the tan of 4 pi over 3, I'm going to use this formula here. Tan theta is sine theta over cos theta. So all I'm going to do is negative root 3 over 2 over negative 1/2. And we'll think back to, what we did with fractions when you were younger, and this is just dividing. So to divide fractions, we invert and multiply. I'm running out of space, so excuse me while I work across. So this is negative root 3 over 2 times 2 over 1. So the 2 divide out, and you end up with, and the negatives will turn into a positive, so you will end up with root 3 or root 3 over 1, which the 1 doesn't matter. So tan of 4 pi over 3 would be root 3. So that's the 3 primary trig ratios. Hopefully that makes sense. So you're dividing the sine divided by the cos. And just to double check that on my calculator, just so we know we're doing it right, so we go tan of 4 pi divided by 3, and we should get root 3, and we do it. So it works. Oh, you can't see my calculator. Ha ha ha. Tan of 4 pi over 3 is root 3, which if you're getting it as a decimal would be 1.73. Then for the reciprocal trig ratios, we're just going to take the reciprocal. So I'll line up, I can't see that. I'll line up sine with cosecant. So cosecant of 4 pi over 3. You don't have a cosecant button on your calculator, or I have never seen one with it. So it's the reciprocal of sine. So it's 1 over sine 4 pi over 3. And I'm the first guy to complain when people work across the map, but I'm going to work across because I don't have space. So this is going to be 1 over root 3 over 2, negative root 3 over 2. And then, again, invert and multiply. So this is just 1 over 1. So flip it around. So that's going to be 1 over 1 times negative 2 over root 3, which is going to be negative 2 over root 3. Okay. If you punch that into your calculator, it's going to rationalize the denominator, which we'll learn how to do later, but for now we'll just accept it as that. For secant, same idea. It's 4 pi over 3. And I'd like to skip this step. So this 1 over thing, since it's just a reciprocal, cosecant and sine are just reciprocals of each other. Secant and cos are just reciprocals of each other. So let's just take the reciprocal of that. There's no need to go through this whole long process every time. So the reciprocal of cos 4 pi over, or the reciprocal of negative 1/2 will just be negative 2. Okay, does that make sense? And then for the cotangent of 4 pi over 3, so it's the reciprocal of tan, so it's 1 over root 3. And we said that this was in the third quadrant, so let's double check. Sine should be negative. Or, I'll just taste chroma or cast thing there. So in the first quadrant, sine should be positive, or sorry, in the third quadrant, sine should be negative, which it is. Cos should be negative, which it is. And tan should be positive, which it is. Okay, so I think I'm actually going to stop there. We're at 28 minutes, and I think you might need to pause and go through parts of this. It's getting a little long. So I'm going to change up. I know a lot of people printed this off, but I'm going to cut the homework in half, if that makes sense, and then tomorrow we'll continue. So can we just do page number 216, number 1 to 3, and I'm adding in 7. So 7, can't see that. So 7 is additional. So I'm adding in number 7. Okay, so it'll be doing this types of thing. And then we'll worry about these ones tomorrow on Wednesday when I get back, because these get a little trickier here. And then the word problem as well. Okay, maybe I shouldn't have zoomed in. You can't see everything that I've done. But you can double check these on your calculator. If your calculator, I'll show you the secant one in a second. To work out secant, it's the reciprocal of cos. Like I said, you need to zoom out. You can see what I'm typing. So it's the reciprocal of cos. So reciprocal of cos just means 1 divided by cos. I'm going to go 1 divided by, I'm going to open up a bracket, which I don't need to do, but I'm going to. Cos, and then I go 4 pi divided by 3, close bracket, and I get negative 2, which is what we got. Oh, I don't know if you can see that because of the glare. Whoa. Maybe that works. Okay. Let's do the cotangent one. So it would be 1 over tan. So 1 divided by tan of 4 pi divided by 3. Now it's going to rationalize it. But it's root 3 over 3. So if you change that to a decimal, it's 0.5773, blah, blah, blah. Double check 1 divided by root 3. So I should get 0.5773 or 0.5774. 0.5774, so it's the same. So it works. And like I said, we'll worry about rationalizing on tomorrow or the next day. We will eventually. Okay. Hopefully that's all you need. Best of luck. You can email me if you have questions. Have a great day.